Picture a call center that wants AI handling real customer calls, not a demo, production. Someone builds a slick prototype in a week, and it falls apart the second a real caller goes off script. So, who fixes that? Not a solutions architect sketching diagrams from the outside, they don't touch code. OpenAI actually sent engineers to embed inside a call center customer, building live evals against real calls while the model was still being built. That's a forward deployed engineer. Think embedded surgical team. They don't advise from a chart, they scrub in and operate inside the patient. Right now, our system status locked out, no access to real customer data. Let's watch them get in. Here's the part nobody expects. You'd think the first move is writing code. Embedded engineer, ship fast, right? OpenAI's engagement is the documented case here. The stage-by-stage shape I'm about to walk is how engagements like it typically run. And week 1 is in code. It's scoping, mapping the call center workflow end-to-end, defining every integration point, writing down exception and escalation logic, agreeing on measurable success criteria, on paper, before a single production line gets written. Just a scope document with a go-live target, signed off by the customer. That's the surprise. The surgical team spends week 1 drawing the incision plan, not cutting. Skip it, and the pipeline you build next has nothing to hold it to. Status update, scoped on paper, nothing built yet. So the scope doc signed, team starts building the pipeline, and it breaks on real calls almost immediately. Not a crash. Worse, it works fine in testing, then a caller goes off script. The escalation logic can't classify the exception, and the call just stalls. No eval running yet to even catch it. This is the actual bite of production AI. A live pipeline where token costs can spike after a routine prompt change, and nobody notices until the bill or the latency does. No monitoring, no evals, no visibility. You're flying blind on a system already talking to real customers. Status update. Pipeline built, breaking on real calls. The surgical team's cutting now, but nobody's watching the vitals. Here's how you actually stop flying blind. You deploy straight into the customer's own cloud. Then wire in evals before the next call even lands. This is the AI layer of the stack. Model integration plus eval engineering, sitting on top of infrastructure work like AWS deployment. The FTE writes a test suite from real transcripts. Does it classify the exception? Does it escalate correctly? Does the cost per call stay flat after that prompt tweak? Now the same off-script caller from this morning hits the pipeline again. And instead of stalling silently, it fails a specific eval. Logged, timestamped, visible. That's not fixed yet. That's failure you can finally see. Status update. Evals running, failures now visible. Evals are running now, so the next failure mode isn't silent, it's loud. Cost per call quietly triples after a prompt tweak nobody flagged as risky. The eval catches the failed exception, but nobody's watching cost or latency drift in real time. That's a different problem than this morning's stall. This is the monitoring gap. Without live observability, you only find a cost spike when the customer's finance team calls asking why the bill jumped. By then, it's been live for days. The surgical team can finally see the wound, but nobody's watching the vitals monitor between checkups. Evals tell you something broke. They don't tell you the moment it started breaking. Status update. Evals running, failures visible. Cost and performance still spiking, uncaught, live. So evals catch the failure, but nobody's watching cost drift live. That's the gap you close next, with monitoring. You wire in observability tooling that watches every call in real time. Latency, token cost, error rate, all graphed continuously, not checked after a customer complains. Same prompt tweak from before triggers the cost spike again, except now a dashboard flags it the moment it starts, not 3 days later when finance calls. The FTE traces it back to the exact prompt change, patches it, and documents the fix for the core product team. That's the surgical team finally watching the vitals monitor during the operation, not after. Status update. Monitored. Cost and performance spikes caught live the moment they happen. So you've got monitoring evals, the pipeline holding under real calls. When do you actually call this done? Here's the arbitration a production engineer weighs. It's not does the code run. Done means the customer's own team can run it without you. That's the real dividing line between an architect and an FTE. An architect hands over a design and walks away. An FTE hands over ownership. With a playbook and knowledge transfer docs, the customer's engineers actually understand. Ask yourself, Could the call center's own team debug tomorrow's cost spike without OpenAI's engineers on the call? If not, you're not done, you're just quiet. Status update. Holds under real call volume. Now the handoff decision starts. Let's talk numbers because expensive doesn't mean anything on its own. AWS just put $1 billion behind this exact model. Thousands of engineers embedded directly inside customer teams, built to ship AI systems in days instead of months. That's the economic bet. Compressed deployment time and the cost of embedding pays for itself. Now, picture the alternative, and this one's hypothetical, not from the case. No scope document, no eval suite, that cost per call spike found by the finance team weeks later. Same problem dragged out for months instead of collapsed into days. So the real math isn't engineers are pricey, it's months of silent failure versus days of visible ones. Status unchanged. Holds under real call volume. So if you were building this call center engagement today, where do you actually invest? Not more headcount thrown at the problem piecemeal. The scope document from week 1, done properly, is the highest leverage thing on the whole engagement. Get the exception logic and success criteria nailed down early, and the eval suite you write later almost writes itself. One documented breakdown puts roughly 75% of an FTE's time in pure technical engineering, pipeline, evals, monitoring. And that only pays off because the other quarter, the scoping and the client alignment, happened first. Skip it and you're back to firefighting cost spikes after the fact. Build it the way OpenAI's team actually ran it. Scope hard, instrument early, hand off for real. So here's the actual takeaway. The call center's engagement is now handed off. Status: customer team owns it. Not because the code shipped once, because the scope doc held, the evals caught what monitoring should watch, and OpenAI's engineers walked away and it kept running without them. If you're chasing this role, that's the whole test. Can you scope, build, instrument, and leave? Not write a demo and disappear. Next video, we zoom into one single feature from an engagement like this and build it end to end, the actual code, not the org chart. What system or workflow do you want me to break down like this next? Drop it in the comments.